Hey guys, so in this video I'm going to make you do a small practice on internal one of the internal data set of scikit learning, iris data set, and we're going to practice for how to calculate the feature importance based on this internal data set. This will let you be comfortable in using these internal data sets, and also let you practice in Python how to calculate feature importance, based on internal data sets. Like one of them is iris data set. This is important so that you get used to using these data sets and get used to using all the features related to these data sets. Features, I mean characteristics, and how to use it and how to use it to calculate feature importance basically. So the first thing we do is from sklearn import datasets. From sklearn import datasets, this will import all the datasets which we have in sklearn stored. Then we do from sklearn.ensemble import random forest classifier. This is a classification database, so we'll use this is basically a classified database. So we have to classify basically based on different characteristics that this particular uh, flower is, whether it is iris or which species of iris is this. So you can also get the details of this dataset in on Google. So very popular dataset, iris dataset. So then we do from sklearn.ensemble import random forest classifier. Then let's have this variable iris. We can also have it iris1, iris2, whatever. Iris I'm taking as a variable, and I'm loading the iris datasets by saying datasets dot load iris and empty bracket. This datasets dot load iris empty bracket. That's how we load it in iris. This is the same as we do when if you can see this in comment, when we were loading the same data from CSV. If we had loaded same data from CSV, we would have done pd.read CSV iris.csv and in df. So that's what I'm doing. Iris is equal to datasets.load iris. I'm just loading everything on iris, all the data frame, all the data in iris. Now let's see what we also have this iris.keys function. Now these keys are available in this data set because we have this data set loaded internally. When we load it from CSV like this, we won't have this facility available with us, right? So let's have it like keys is equal to iris dot keys, and what it gives us, I'll just print it, and you'll see. So these are the keys, these are the things we can print from the data set, like data, target names, description, feature names, file name, right? So print or store whatever. So now I stored the data iris.data in X, then iris.target in Y. Now we can separate this. As I said, we have these keys available, that we just write iris.data and we get all the features, all the variables here, and we write iris.target, we get the target variables here. But in our case, if we had used CSV, we would have used these statements, df.ilog, and then up to what columns we want the data, which is for basically which will be used as features, and up to what column we want the data which will be used as targets. So because here they have already separated data and target, so we can just write iris.data and iris.target. So we have already used these statements in our earlier videos. So right. So basically iris.data, iris target is the alternative for these statements, right? Iris is equal to datasets.load iris is the alternative for this statement. Perfect. So now we have our data in X and our targets in Y. Now we can also have our basically feature name, which is also available as another key in iris dataset, again because we have it internally loaded. Otherwise we would have extracted the column names separately. So features is equal to arrays dot features name. So I have just named all the features here, right? Now I'll again, take the target names in targets. Now, I'll, initialize our forest classifier, like RND CLF is equal to random forest classifier, random state. We have already discussed this. Random state 0 and estimator is equal to 100. Now, by the way, an estimators tells us how many trees we want our random forest classifiers to have. So how many uncorrelated trees you want it to have, and random state tells us that whether the data needs to be readjusted every time. Usually we want it constant so that when we debug it, we are able to debug it successfully. Otherwise it will be very difficult if the data changes every time, and the data classification changes every time. For example, testing and train data changes every time. So it will be difficult to debug. So we make it constant so that the data remains same whenever we run. So yeah, so basically now we fit it here, and here, after initializing it in RND CLF, we fit it here. And then once we fit it here, then our random forest classifier function knows that what features are important for in our data, because it already knows what is target and what is data. This is data, X is data, and Y is target. So now it has fit it in the data. So now it knows the feature importance. Once we run this function, of course, after this function. So once we run this function, it knows that RND underscore CLF dot RND CLF. Why? Because we initialize with this variable. That's why we're using RND underscore CLF. So RND underscore CLF dot feature importance is underscore again. Dot feature underscore importance is underscore again. When we use this function, it will come to know that what features are important for this data to get these targets, which are in Y, because it already fitted itself into this data. So now when we run this function, it will come to know that what features are important. Once it knows it, then we'll probably make the pairs of features and feature importance like this. Zip basically takes, if there are two arrays or two lists, it takes the corresponding values from each list or each arrays, and merge it together, basically place it together. So that's why we use zip here. So sorted zip, and then we want to place feature corresponding values for feature importance and features together. That's why we are using zip here. Now sorted zip feature importance comma features, then reverse it. I'm just sorting it, that's it. So I'll print importance now, and you will see that it will load everything. So now it has all the features in the feature importances in descending order placed here. So that's how we can calculate what features are important and what features are not, and we can accordingly select that. Okay, I only want 2 features, so I'll just put first 2 features, and I only want 3 features, I'll select first 3 features, and accordingly. So that's about it. So that's how we basically calculate feature importance with random forest classifier. And yeah, thank you.